Hello everyone. Today I'm gonna talk about the intermediate fusion techniques. I am Saeed Farzi. I am a senior AI researcher at the Fantasy Bruno Kessler, working on the large language development and a large language model in the healthcare. In the previous video, I was talking about the early fusion models and techniques. Today, I'm gonna explain a bit intermediate fusion technique. Each model in this technique, each modality is processed by an individual model. Future representation are extracted and then concatenated. The final model learns with a combined feature space, and the last function, last value is back propagated through the feature extractor. Let me explain this technique, sophisticated technique, in this with the help of this flow chart. H color refers to the H modality. For example, here we have a text, blue refers to the text, and yellow refers to the image. Feature extraction model, feature extraction model. Each model has its own feature extractor. Text feature extractor, image feature extractor. Produce the embedding vector. After producing the embedding vector, we need to combine them. We need to aggregate two feature vector, aggregation function, aggregation method, concatenation, the simplest one, average, or maybe you can use the attention layer here in order to aggregate two real value vectors and produce the one unified real value vector. After that, it's fed to the model. The last value is used for training and calculating the gradient for this model and this model and this model. Of course, it's a data hungry. It's a data hungry. It needs lots of data to be trained. Training process. Pre-training models separately on the individual modality. Pre-training this model, this model. Features are extracted separately before being merged. You can see here before they merged. Extracted features are then combined and passed to the final model. Advantages of this technique. Let's dive deeper and discuss a bit more. More abstract and refined feature extraction capture complex interaction. This is advantages of this model. Advantage of this model. Flexible architecture. Different modality process separately before fusion. Preserve modality specific information allows better feature alignment. This is very important. Apart from the fusion technique, in the multimodal neural network, the alignment technique is very crucial. Exactly like as important as fusion technique. Let me talk about the challenges. Higher model complexity. Of course, we know we have at least three models here to be trained. Data hungry, we need lots of data, and of course, computational overhead. In cancer detection, fusion of the pathological images with the genomic and demographic data. This is one of the good application of this technique. In cardiology, combining X-ray images with the biomarkers and clinical measurements. In neurology, merging MRI scan, genetic information, and demographic, there are three different modalities to predict the brain disorders. I list all the published paper, latest published paper here in this video. Thank you for your nice attention. In the next video, I'm gonna talking about the late fusion and mixed fusion techniques. technique. Have a good time. Take care.